It's a pleasure. Always it's good to be connecting with the universities and sharing the work, learning from them, from my old teachers, and sharing what we are doing in the industry. So today's presentation is about what can be the possibilities of petroleum provinces in the midst of the mountain ranges. Since the topic was Himalayas, so I will limit myself to the potential sedimentary provinces which may contain hydrocarbons. So starting with this slide, I presented last week at the CPEC Earth Sciences Research Center at Qaidiaz University, and these two maps are from that presentation. It shows a regional sort of scenario with how the pipelines, the energy corridors are moving around, or might be moving around. The cyan is, if you can see my cursor, cyan is the CPEC route going through the Kirthar Fold Belt, going along the Suleiman Fold Belt, crossing the Kalabagh area, and then going into the Skardu and the Punjab, and then China. And on the right side is the global view of the same. You can also see the red color lines. These are the planned TAPI, Turkmenistan, Afghanistan, Pakistan, potential India route, and how that comes into Pakistan. So really the access is everything. So I'll skip this slide. I'll show you a little bit of, give you a little bit of intro about petroleum value chain, how the fossil fuels are gonna be prevailing, continue to prevail on the energy landscape for next couple of decades. Just to confirm, are you comfortable hearing me? Armagan?
Yes, sir, we are comfortable. You should continue.
Okay, so continuing on, so really what the upstream oil and gas businesses we explore for the subsurface geology and for the subsurface traps. And this is a sort of a block diagram showing you how the kitchen is formed, and from the kitchen how the hydrocarbons move out and fill up the traps. So the traps can be structural, those can be anticlinal, those could be stratigraphic, as I have tried to show here on the left side of the block diagram, and those could be also the shale gas and the tight gas, and the tight gas can be very deep, and that would be the basin-centered gas. So in the petroleum value chain, exploration is really the point where the value is created. In rest of the parts of the petroleum value chain, we mature that, add value to it, and bring it to the market. So, so therefore, we heavily depend on the surface access, continuity of the surface operations and the infrastructure, and therefore the market proximity. In recent decades, couple of decades, sustaining the reserves base have been quite a bit of challenge. So we have to sustain, and then we have to continue to grow. And in doing so, therefore, we need to bring new basins and new plays into the reach of the exploration companies. And in that, the topmost risks that we have are the size of those traps and the reserves, and the fiscal regimes, and timely onset of the operations. So the frontier basins are really the focus these days, because we have matured the areas which are within our access, such as the platform areas of the lower Indus and middle Indus, the Potawar, and to some extent the Kirthar Fold Belt and the southeastern part of the Kohat, Banu Kohat Basin. So really the E&P companies' next decision of a new basin entry would be whether or not there are new plays and traps in those basins, and what could be the new play concepts and the trap concepts. So today what I'll do then, take you through a couple of examples and bring you back home to a couple of basins where new work is needed and where you can also contribute. So regional corridors that I talked about in the very beginning, and this sets the stage also for the energy, for the E&P landscape that exists in the country. On the left side, the greens are the basins which exist in the area in Central Asia, in South Asia, and Middle East also. And these greens are where we have been exploring. But today we will also try to go into the fold belt area and see what exists there and what can be potentially worked on and potentially be brought into the exploration reach. So on the right side is the map of Pakistan and the adjacent countries. The Himalayas are running in the north, and this swinging fold belt is the Kirthar range in the south, and it swings up at the Sibi re-entrant, and that's where the Suleiman fold belt starts and goes north into the Himalayan region. The red is the Tapi pipelines, future paths if it matures, and there's work which is being done at the moment, and there's Iran-Pakistan pipeline in the south. So so far so well. The black dots are the wells which have been drilled so far, and you can see the density of the wells is more in the platform area and in the outer parts of the fold belts, which are accessible, and that's where the exploration is happening. Why we don't see the density in the interior of the fold belts and also in the northwestern part over here, the western part of the Banu Kohar Basin, that's partly because of the access, because of the security, but really is the geological concept. We have seen that the companies venture in, they spend billions. If a sound geological concept is there, they go in and they do it anyway. So we have seen countries which are in turmoil, but still the companies are there and they are exploring. So it's really the depth of the concept that matters. And if we do sound technical work with plausible explanations, present that to the oil companies, maybe national oil companies, and they have the resources and they can spend money on early sort of maturing of those concepts. And once the concept is matured and the area, the risks are removed or minimized, then the international oil companies also start coming in. So that the whole thing comes within the appetite of the international oil companies, and that's the message I wanted to convey. So far so much of the oil business. Let's go into the geology. On the right side, you see tectonic and structure map of the petroleum basins of Pakistan. Since we are more interested towards the Himalayan part, into the upper Indus Basin, so I would not spend a lot of time on the Kirthar Fold Belt and Suleiman Fold Belt, and on the Haran, Forearc, and Back basins. So I'll go to the northern area. So Pothohar has been quite a bit of explored basin, and now companies are moving to the subthrust play. That's a play that is less explored. That's where the value is. All the hanging wall plays, most of those have been drilled out, and those are well imaged also on the seismic. So really the subthrust is the next game changer, I would say. On the left side here, across the Indus Basin are the Trans-Indus ranges, and the red line is the MBT that runs through, and north of it is the Gerad Range, and then the basin that we call Peshawar Basin, and the East Peshawar area. And towards west is the Jalalabad and Kabul province, and that's where also the potential exists. On the lower left side are again the regional picture, big picture. It shows the map and the wells on the map, and it shows the densities. Density is much more in the platform areas in the lower Indus Basin, middle Indus Basin. The center is almost is not so very well covered, and then the north, the Potawar area. So moving on to the next one. I give you a little bit of stratigraphic framework. All day yesterday and today, you guys have been listening and talking about it. So I would not spend a lot of time on it, but really today that what we will be talking about as far as the stratigraphy of interest is, are the infracambrian sequence. So on the in the left side, lithology column shows those formations. So that's the infracambrian section that you all are aware of, and the potential source rock are the infracambrian shales, which are proven on the platform area towards India side, Bhagewala, and we have the exposures also that have the oil shales in it. And then going up into the shallower part. In the Permian also, we have coals in the Permian section, exposed in the again salt range area, and also drilled. And over there, we also have the potential for hydrocarbon source rock, and that's why the question mark is there. Then comes the infra-Jurassic. Again, there's a source potential in there, but really the proven source is in the equivalent of Chichali and Lower Guru and Sambar formations. And in the north, these are over mature, but we believe that Chichali have been producing in the past, and it still might have potential. And by Chichali, I mean the lower part of Lumshival, which are the progradational part, which contain the organic rich sediments. And then going up into the shallow, the Paleocene, and the lower Eocene, that's where the most famous source rock is the Patala formation. Also, the sources in the Lockhart's organic rich parts also, and the other sediments in the called with different names. And then there's a major unconformity in the middle part of upper middle part of the Eocene, and then comes the Oligocene and Miocene sediments. That's where most of the speakers have been talking about. These sediments have been studied in detail. Their sedimentation have been studied in detail, and today you heard from a number of colleagues about it. In terms of basins, sedimentary piles, Doug Burbank is one of the quite active stratigraphers, tectonic sedimentation specialists who have been working in this area. So I wanted to mention that name, especially because he has spent quite a bit of time on this. On the left side is the tectonics movement of the Indian plate, how it moved up north, and how different sediments were deposited. So Paleocene, Hungu and Lockhart; in the south, the Ranikot and the Dungan; and in the upper Paleocene, Lockhart, and then part of Patala that goes into the lower Eocene also. And then we have in the Banu-Kohart Basin, we have Panoba shales coming in, and Margla Hill limestone. And similarly in the Potawar also, we have Margla Hill limestone, and Panoba Basin and the Evaporite Basin continues in the middle part, lower to middle part of Eocene. And then we have the Cohort limestone in the Banu Cohort Basin. And that's where the story of the platform sedimentation starts. And we have the molasses coming in that kill the carbonate platform, and the different small basins are developed. So moving forward to the next part. So this is what you have seen a couple of times, quite a few times before. But this is again the tectonic framework of the northwestern Himalayas. Here the points of interest, again the Indian plate at the time of late Permian. That's where the going into the Triassic time. That's where the Neotethys was developed here. Khoistan Arc was up in the north, and with time this plate moved and rammed into that Khoistan Arc sediments, and later on also jointed with, docked with the Eurasian plate in the north. So there were incipient sedimentary depositors during the course of this Indian plate movements towards north, and those depositors developed in the Cretaceous to Pliocene times. Those sedimentary, most of those sedimentary wedges in the Tethyan were really exhumed. They are gone, they are eroded, folded, but we see on the right side map, we see that there's Ladakh range here, and there's Indus sort of suture here, and this suture in the northeastern part and the one on the northwestern part, they really reflect the escape tectonics. You have the tectonic sheets which are being thrusted out laterally along the strike towards east, and also on the Indus part, they are being thrusted out, thrown out, spewed out towards the left, towards the west, and that what that does is, and that's partly because of the rotations, because of the wrench development, and what that does is that creates sort of extensive transgression, but also along the strike towards west, it creates accommodation space. It creates differential stretching, and that's differential stretching, accommodation space. There are sediments which are preserved, right? Not only the platform sequences of Paleocene, Eocene, and the older age, the Jurassic, Chiltern, Lumshival, and that part, but also the younger sediments of the Neogene age, and that's where this these small basins are developed. So Peshawar Basin is one of those. I'll take you through a number of other basins. So that's the message I really wanted to give you today about these parts north of the MBT, and that also applies to the Banu Cohort Basin over here. Moving on. Here I have tried to explain how the thrust loading during different orogenic phases causes the subsidence of the foredeep and the distal peripheral bulges. And this is a diagram coming out of my PhD dissertation, and the area of interest was the Illinois Basin, the Ohio area, and the Illinois area, and there were appellations in the east. So appellations in the east, and that would be equivalent to, let's say, Himalayas in the north to us. So during the thrusting, the sediments are deposited wherever the sea has the access. So the embayments make it into the continental parts also, and you start getting these wedges and sedimentation. When the thrusting calms down during the interorogenic phase at times, what happens is that viscoelastically and isostatically, the foredeep and the and especially the peripheral bulge areas, they pop up, and there's extensive erosion that happens over that area. And we see that on the Mari Jakbabat high, we see that on the Sargoda high, and also there are highs buried down deep in the Potwar area and north of the MBT. I'll talk about that a little bit in the coming slides. Over there also, you would expect the erosion of the sediments of older ages of the Paleozoic time. So keep that in mind. And again, when the thrust loading happens, again, same thing, the seas start coming in and the deltas start developing and until the next quiet times happen, and then again the uplift happens in the foreland and foreland area. So if that message is clear, then that means that these foreland areas like our Punjab platform or Sargoda high area or wherever those ridges are, those will provide barriers to the sediments. Yeah, so the sediments will be trapped towards north. And that is what happened to the Panoba Shale, how the Panoba Shale got developed. Very thick in the Kohad Basin, Banu Kohad Basin. And that one is ductile, thick, and it gives you a very good lateral seal across the faults. And also an excellent top seal. Yeah. So there's more that I have on that topic, but this is not the forum to go into that detail. So moving on, so that gives you a very good Pertala low-carbon petroleum system. Moving on to the next slide, then. So what I'll do, I'll take you through a couple of 2 or 3 analogs that where you have faulted underlying systems, faulted, folded, horse blocks, grabens, where the petroleum system works, right? But those are buried under a sag, under a platform sequence, and then during the later time, those hydrocarbons leak into the shallower sag sequence, and that's when the hydrocarbons are trapped in the overlying sag sequences. So this is an example coming from North America. Those who know, this is Florida Panhandle. This is the area I was just talking about, the Appalachians here, the Intermontane Basin here, and this is where the Alaska is. And the zoom of this area is here. This is where the subduction is happening, and this is where those island arcs are. And this section is coming north-south along this line, approximately. And so this is the North Aleutian Basin, and that North Aleutian Basin is over here on the satellite image. And that's where there's older Mesozoic basin that I talked about here, and above that is the tertiary basin into which the hydrocarbons leak, and those are then preserved, and those are being produced. This is the petroleum system diagram of the same system. So the horst areas tend to contain hydrocarbons, and those hydrocarbons then leak into the shallower part. And again here, this is a faulted part, and the hydrocarbons leak into the shallower part, and those are preserved here. Keep this in mind when we talk about the younger basins, the Peshawar Basin or Helmand Basin or other basins that we talk, or even Kashmir Basin that I showed earlier on. So this is a regional cross section. The kitchens are down deep in the Mesozoic strata, and those are charging the shallower platform sequences. Moving on. So again, that one was the North Aleutian Basin was coming from Martin 1990, and you can Google that with the name of North Aleutian Basin. You can get the papers along those lines. This is coming from the Central and East European Basin, the very famous Carpathians, where there's Pannonian Basin, which is well known, and there are a number of smaller basins. Vienna Basin is here, Travas Basin is out here, and this is a diagram on the lower right side, which shows a highly folded sequence. And that highly folded sequence contains the petroleum source rock, the reservoirs. People have been exploring that. And then the younger basin that I was talking about, like Vienna Basin, those are sags which are sitting on top of those, developed because of stretching and the subsidence of the older sequence. And in those, we have then the petroleum place. Now, in this case, petroleum source rock is also present within the Miocene of the sag sequences. And in some cases, the hydrocarbons, the oil, the condensate and gas, they leak from the underneath and they charge the overlying sequence wherever there's a breach and the overlying source is not so competent. So that's where the hydrocarbon make it into the shallow part. This is a regional section going from east towards southwest. And again, this is the faulted part of the southeast Carpathians. And then there's a sort of foreland part coming here. In the foreland, you see these red color, the purple color, the sag basin, the remnants of the previous basin, and overlying is the Oligocene, Miocene, the very top skinny layer. And into this top skinny layer, the hydrocarbons sometimes leak and then those are preserved. But these also contain their own petroleum system as well. So moving on, coming back home, this is a landscape of Pakistan on the right side, Afghanistan on the left side. You can see the yellow color country boundary, Peshawar Basin in the very north, Suleiman Fold Belt on the right side here, and behind that is this piggyback basin, the Pasheen Basin. So the Suleiman Fold Belt strata, which are proven hydrocarbons, those have been thrusted under the Pasheen Basin. So the way the petroleum system would work, it would get hydrocarbons from that into the Murgha Fakirzai and the younger formations of the Pasheen Basin. So that's how the petroleum play concept should work, might work, and that needs extensive work around it. So the Peshawar Basin is out here, and there's Afghan Tajik Basin which is sitting out here in this area. It's East-West Basin, and it has strata of Tethyan affinity. So Tethyan affinity being Jurassic carbonate, which are refoidal and extensively burrowed and very porous and permeable, overlain by the salts, evaporites, and that makes them a prolific reservoir of the Jurassic age. Equivalent to that on our side is the Samanasuk Formation and Chiltern Formation. But there's a difference of climatology and the skeletal grains, which make the Tethyan carbonates much more porous, permeable as compared to the Gondwana shaft margin carbonates, the southern South Tethyan carbonates. On the top left side is the geological map of the Afghanistan area. So the red is the part that I told you about. This is this part here, and then we have the Chaman Fault, and then the Helmand Basin. This part here, and then the Hindu Kush over here, and to the north is then the Afghan-Tajik Basin running over here. This is a view of Afghan-Tajik Basin looking from east towards west. So from here looking towards west in this direction. So this is the Amudarya Basin, Amudarya River basin is up to the north. So Amudarya River runs through this area, and this is a very narrow sort of trough, highly folded. And in that trough, again, the high rising mountains in the north, the folds are striking north-south, and suddenly culminating against this basin over here. And give you a subsurface view of that Intermontane Basin. So this is an east-west view of that. So Jurassic limestone that I talked about earlier, overlain by the salts. So wherever the salt is on top of it, you get the play working. So salts are very good top seal. And the example that I gave you before from the Cohort Basin, that role is being played by the Panoba mudstones, Panoba shales. Those are again very ductile, and no matter how the rocks are folded and these give you a very good top seal and lateral seal. And there's a Paleocene strata sitting up here, limestones. And now where you see these folds, very tight, narrow folds, that's where the salt is intruding, right? And you're getting those, and all of that sequence is being truncated here. You can see that it's being truncated, and there's then platform sequence on top. Now this is the sequence which is equivalent to what we see in our area in the Peshawar Basin, where because of the quiet times, then these layers of sediments are formed. Now this is the after this example. Now let me come back let me come back to the come back home. This is a regional map showing looking northeast. Potwar Basin is on the right side. Banu Kohart Basin is on the lower side of the slide, and the green lines that you see, those are the exploration blocks that we have in this area, right? And the MBT, many of you can recognize as this black line running through, and Gerad Range is this one, and coming down and joining the MBT over here. To the north is the Peshawar Basin. It's a sort of piggyback basin, you may call it. It's formed because of this uplift along the MBT and accommodation space that created, and that's where these sediments were deposited. Now recall what I said before, there's wrenching, and because of that wrenching, less accommodation space to the east and more accommodation space to the left towards west. And that's where then you may expect that these sediments, if present in the subsurface, may provide you hydrocarbon charge into the shallower sediments. Moving on to the next slide, giving a little bit of more detail. Slightly rotated, the same section. On the right side is your south, and on the left side is your north. On the right side, upper right side is the Potwar Basin, and the Banu Kohart Basin is on the lower right side. And then you have this mountain range coming through, and towards the west of it is the Peshawar Basin. And it's looking from west towards east, and towards west where the Jalalabad is. This is a basin that joins with Kabul, and this is another area where the hydrocarbon potential exists. Moving on, this is the same thing overlain by the geology. So the geology is such that you have the Paleocene, Eocene, and also the Jurassic exposed here, and then you have Gerad Range, where you have the older strata exposed, and I'll show you in the next slide what is exposed there. This is the geological map, Gerad Range, and joining this MBT area, and there's a basin that is developed up north. What is exposed then over here in the Gerad Range? Now this is coming from the PhD thesis of Kevin Polk, 1993. He looked at the whole area of northwest Himalayas and prepared cross sections. So this is one of the cross sections, which is looking at the Cherat and Nusheira area and correlating that with the Salat area. The message here is that the whole Permian is intruded by dikes, right? And you have the Abit About equivalent group here, and then you have the Permian section, and the dikes stop at the top of the Permian. So post Gondwana split sequence, these sediments that we see here, those are not intruded by the dikes. That is undisturbed part. It is disturbed only because of the later tectonic movements, because of the post-Paleocene tectonics. So this is the platform sequence then, right, after the Permian. So that platform sequence, that means, is present in the Peshawar Basin, right? And then that platform, so again this correlation, this is the Atak-Cherat range over here, and this is the Abit About section. And all of you have go to Abit About section where you see the Abit About group in detail, right? So that is this, and this is the Nusheira, and you would see a thickening of all that section towards north. So these regional grabens preserve these older strata, and where the highs have developed, there these older strata are eroded off. That's what I tried to explain in the earlier diagram, where I showed you thrust loading, the extensive orogenic times, and then the interorogenic quiet times. So the regional horse blocks get the strata eroded from them, but in the regional lows, those strata are preserved. That's the message, and that's what I'm trying to say here, that the platform sequence got established on top of the post-Gondwana horst and graben system. Regional scale paleo highs receive erosion, and the grabens are where the strata are preserved. Subsurface then should contain the Paleocene and Eocene proven source strata, the Patala or even the older ones from the platform sequences. Platform sequence being from Chiltan and Chalilam Shival equivalent all the way to the Patala and Lockhart. And then we expect the infracambrian also present, and we know that infracambrian has the source potential. So the sag that is developed on top of all of this, right, that should, if it contains a suitable seal rock, then these hydrocarbons should be in there. We have seen the seeps in the Banukohat Basin along those slivers that I showed you before, and those wrench left stepping shears on which we also have the discoveries. So the hydrocarbons are present on the surface, they get leaked into the younger sediments. So same you may expect in the north. Doug Burbank has done a lot of work on the Cenozoic sediments in these piggyback basins, and he shows correlations where lacustrine muds are extensively developed, and those are pervasive throughout the basins. So those mudstones in the Oligocene-Miocene section would provide you the top seam. So this is basically the message that I wanted to give you. Now these seismic section, thanks to Tahir Maqsood, he shared these with me. I did not put a lot of references here because we are online, and I don't know where it would go with this. But this is showing you going from MBT, just north of MBT, going through the Nowshera and going up north, right? And this is where the I showed you one of the sections from Kevin Polk's dissertation thesis. One section was from here where the Permian was exposed, and that's where the Nowshera famous Silurian reef is also there. And you see these depressions developing. Now compare those with what I showed you from North Aleutian Basin and from East European basins, right? This is potentially the Paleocene, this one, right? And if this is the platform sequence sitting in between this whiteout sequence, or if this black is the platform sequence, then we have something in the making there in Peshawar Basin. And you see similarly these kind of sort of regional grabens features. This is again east-west line going through the Peshawar Basin, right? So this is what needs to be studied. There's there's room, a lot of scope for additional work and collaborations at multiple levels. What you need to do is really bring in the analogs, bring in the experience, the eye that has seen many different basins across the world, right? Similar basins. And that's where you then have to bring the industry and R&D together, right? So that's why I have this slide. This is where these are the key data sets that we play with, which we can work with. And what we need to do really then work on the methods and tools and the technologies for collaborative R&D. So where we can work is the 2D seismic lines. The next generation 2D seismic lines are what we call wide lines or fat lines. So what you do is you carry out closely spaced, laterally placed geophones, and then you shoot on two sides, right? So you get a 4 or 8 in parallel 2D lines which you merge together and make a fat line, right? It gives you a very good, better resolution in these kind of terrains, in these kind of hilly terrains, carbonate on top, limestone on the top, which doesn't allow you deeper imaging. So this is the solution then. Then there's 3D seismic, we all know about it. So you don't have to do the good old regular 3D seismic. You can live with a sparse 3D. Increase your bin size, and that gives you 3D coverage, right? And seismic processing, there are many improvements that have come in, right? And that needs to be brought in the industry's R&D side has to look at it in these kind of basins. GIS and remote sensing, I'm happy to see good work being done where the satellite images, different channels are overlain and reprocessed, and the images which come out, they bring out the stratigraphy and the structural features. So it's being done in ARDAS, it's being done in ArcGIS. We need to develop skill along these lines, number one, and then use that as if this is our day-to-day tool, right? So all the students in the university, ArcGIS is a must when you go to the industry, right? Then the plate reconstructions. right? So we do regional plate reconstructions, and that's where we identify these smaller basins, which are hidden, in the middle of the mountains or in the middle of nowhere. So, and a lot of time those smaller basins are conceptual. So we go in with more data and try to find those, shoot seismic, and then if something is good, we drill it. So that's the plate reconstruction. So reconstruct your basins and plays. Potential field data, gravity and magnetic, aerogradiometry, Falcon methodology is there, has been done, SFD, stress field, has been in Pakistan for some time. So this is again something that we should be working, right? So don't hesitate to even reach out with the military agencies. They also carry out these kind of data. Falcon is the technology that U.S. Navy invented, and then later on in late 90s, early 2000s, they brought it out in the open. So Apache and those big companies, those companies got it and they developed that, right? So, and then of course the cores and cuttings and their specialized core analysis and the logging and the processing. This is all then subsurface data. So these are the areas where the academia can really come in and start using that to reconstruct your basins. This is all I wanted to show you today. If there are any questions, I'm happy to take.